Hello all. Welcome to 4th week of International Faculty Development Program on Environment and Sustainability. The topic is Way to Reduce Your Computing Carbon Footprint. Here are the details of Week 1 and Week 2 videos, with its number of views and likes. After learning through video, students will understand. First, what is carbon footprints? Second, effects of carbon footprints. Third, ways to reduce carbon footprints. Fourth, ISO standard for carbon footprints. A carbon footprint is historically defined as the total greenhouse gas emissions caused by an individual, event, organization, or product, expressed as carbon dioxide equivalent. Greenhouse gases, including the carbon-containing gases carbon dioxide and methane, can be emitted through the burning of fossil fuels and clearance in the production and consumption of food, manufactured goods, materials, wood, roads, buildings, transportation, and other services. In most cases, the total carbon footprint cannot be calculated exactly because of inadequate knowledge of and data about the complex interactions between contributing processes, including the influence of natural processes that store or release carbon dioxide. For this reason, Wright, Kemp, and Williams proposed the following definition of a carbon footprint. A carbon footprint is the total amount of greenhouse gas emissions that come from the production, use, and end of life of a product or service. It includes carbon dioxide, the gas most commonly emitted by humans, and others, including methane, nitrous oxide, and fluorinated gases, which trap heat in the atmosphere, causing global warming. Usually, the bulk of an individual's carbon footprint will come from transportation, housing, and food. You can start the process by calculating your carbon footprint here. You will need to know the following: approximately how many miles you travel by car, bus, train, and plane. The energy usage in your home. How much you spend shopping. The composition of your diet. Of course, the carbon cycle nowadays includes more than just natural phenomena. We produce and use products and services that contribute to the carbon cycle in one form or another. Take, for instance, driving a car. The car relies on gasoline to drive. Gasoline is derived from very concentrated carbon stores, fossil fuels, that have accumulated underground over millions of years. So, in order to produce the gasoline, we extract these hidden carbon stores, convert them into gasoline. And the car converts the gasoline into carbon dioxide, and other greenhouse gases, as part of its exhaust. These greenhouse gases then accumulate in the atmosphere faster than natural phenomena can take them away. Why? Well, remember, the planet can only take up so much carbon dioxide out of the atmosphere at any given moment. And what we've done with fossil fuels is extracted and used millions of years' worth of carbon in just a few decades and put it up into our atmosphere. This overaccumulation of greenhouse gases in the atmosphere serves to trap heat on our planet. Thus, the car has a definite carbon footprint. The overabundance of carbon dioxide that gets trapped in Earth's atmosphere can lead to numerous problems. For instance, land ice melts into the oceans at a fast rate, and this leads to the levels of our oceans and seas rising. In turn, islands' communities are becoming submerged, and there is a real threat of the same thing happening to large coastal cities around the world. The more carbon dioxide that a product, service, or event releases into the air, the larger its carbon footprint becomes. Carbon footprints have a great impact on the environment and world in which we live. The effects are numerous and widespread. Reducing greenhouse gas emissions will increasingly become the responsibility of all global citizens. In the Caribbean, most countries have not yet implemented comprehensive green-oriented programs. As discussed in an earlier post, making the world a greener place. Decreasing ICE's carbon footprint, managing our electricity consumption can reduce the carbon footprint from PC use. 5 options are outlined in next slides. Although this recommendation might seem obvious, a desktop computer with a CRT monitor can consume the same amount of electricity as 3 or 4 bright, non-energy saving, lights on full time. If both the monitor and CPU are left on for 8 hours, the average workday, 5 days a week, in a month up to 58 kWh could be used. Further, if they are left on all day, every day, and are not configured to go into sleep/standby mode, or to switch the monitor off when not in active use, electricity consumption can jump to as much as 245 kWh per month. Most PCs have power management features that allow users to configure electricity consumption by device. Typically, users are allowed to choose settings for when the equipment is fully operational and actively being used, and for inactive periods. Depending on the manufacturer, a range of options are given, such as power saving options when the PC is in active mode, turning off the monitor after a specified period of inactivity, turning off the CPU after a specified period of inactivity, activating sleep/standby mode after a specified period inactivity. Although screensavers are a way to personalize your PC, when they are triggered, they can keep both the computer and monitor active. No power savings are realized. However, some might contend that having a screensaver shields the images on their computer screens from prying eyes. If this is a concern, the power saving settings of the PC should also be activated to eventually switch off the monitor, at the very least, if the PC remains idle for an extended period of time. There are a few software applications that claim to monitor and manage the power consumption of PCs, with the aim of realizing significantly lower electricity bills. Most are targeted at enterprise network environments, such as GreenTrack, Jowlex, and Night Watchman, but a few such as Granola are designed for the individual PC. There is also Wellectricity. Wellectricity is a social network that provides a free online service that helps its members track and reduce their electricity consumption at home. Wellectricity was developed in St. Vincent and the Grenadines, in the Caribbean, and is currently being used in 78 countries around the world. As reflected in the above table, there is direct relationship between the equipment used and power consumed. For example, laptops are considerably more efficient than desktop computer systems. However, laptops tend to be more expensive than desktops and generally, they need to be replaced more often than desktops, which can be more easily upgraded or have parts replaced. Further, greater care and consideration is needed when selecting laptops, as the environmental impact of their manufacture and disposal should be factored in. For guidance on the most environmentally friendly laptops, see the Guide to Greener Electronics. Customers, consumers, and shareholders are increasingly concerned with the environmental impact of the activities, products, and services they consume. This may be a challenge, but it is also an opportunity. Carbon footprint verification enables you to demonstrate your environmental responsibility, stand out from the competition, and show existing and potential customers proof of your commitment. Your organization can demonstrate its commitment to reducing the impact of its daily operations on the environment with carbon analysis by meeting the developing ISO 14067 standard. Additionally, it is increasingly possible to purchase more energy-efficient computing equipment. The most widely recognized standard is Energy Star, which is an international standard used for energy-efficient consumer products. There is usually no appreciable difference in price for Energy Star-compliant products when compared with other non-compliant devices. It is therefore strongly recommended that energy-efficient options be considered. Here are the references I used to prepare this presentation. Thank you.